Hello everyone. Today we will see what is big data and advanced analysis. So big data, it refers to the data sets that are too big to handle or too large to handle, and these are complex or fast moving to be efficiently handled by traditional databases and the processing tools. And these big data, these are too big to handle. That is, the size of the big data exceeds the capabilities of the conventional database management systems, that is the DBMS, like MySQL or Oracle. Then these are the there are two types of diverse data types that are structured data and the unstructured data. So in structured data, here you will be having the data which is organized, which will be in tabular form, and in unstructured data, the data will be free flowing, raw data. You have like social media posts, images, videos, and emails. And the sources of the big data are social media, that is Facebook, chats, and tweets, comments. These all are the social media sources of the big data. And you will be having weblogs, that is website visitor data, and media content, that is news articles, images, videos, and real-time sensor data. Next is the definition of the big data by NIST, that is National Institute of Standards and Technology. So here, according to NIST, the big data, it represents the data of which acquisition speed, data volume, or data characterization, it will restrict the capacity of using conventional associated methods in order to manage successful analysis, or the data which can be successfully operated with important horizontal zoom technologies. Meaning to say is, here the big data, it emphasizes high acquisition speed. Okay, that is, data is generated and collected rapidly. Then you have large volume where the data exceeds traditional processing capabilities, and you have complex characterization, that is, the data may be structured, unstructured, multimodal, or highly variable. Then you have challenges with conventional methods, that is the data processing techniques struggle to handle this data which is complex effectively. And last is the horizontal scaling technologies, that is big data solutions, it rely on the distributed computing such as Hadoop, Spark. Then you have cloud based architectures in order to manage and analyze the data efficiently. So you have mainly two types of data types here. First is the structured and second is the unstructured. So the structured data type, it is highly organized and easily searchable in databases. It follows a fixed format, making it easy to store, manage, and retrieve the query languages like SQL, that is structured query language. Okay, and the characteristics of the structured data are, it is easily organized, that is it will be stored in the tables with rows and columns. And here it is stored in relational databases. Okay, that is, it is managed by relational databases management system, that is RDBMS, like MySQL, Oracle. Then you have uses SQL for management, that is queries can be performed using structured query language, that is SQL, and it takes up only 20% of the global data, that is most of the data generated today, it is unstructured. Examples are customer databases, that is it may be name, age, address, email, phone number. And you have financial transactions, that is the bank records, stock market data. Then you have employee records, it may be ID card, salary, departments. And you have inventory management, that is the product ID, price, or the quantity. Okay, this is about the structured data type. Then you have unstructured data type, where it refers to the information that does not have a predefined format or a predefined model. Unlike the structured data, it cannot be easily stored or managed in traditional RDBMS, because it does not fit neatly into the rows and the columns. So here the characteristics of the unstructured data are, these are it is a no predefined model, that is the data is not organized in a structured manner, and it cannot be processed by traditional RDBMS, and it requires big technologies like Hadoop and AI based tools. Then it provides deep insights, that is advanced analytics, machine learning and artificial intelligence. These will help to extract the meaningful insights. And you have global data prevalence, that is accounts for 80% of the global data. Here the majority of the data generated today, it is unstructured, and examples are the text data. Okay, that is here you'll be having the emails, then you have customer reviews, survey responses, and in social media data you'll be having Facebook post, tweets, comments, and YouTube videos. In multimedia data you'll be having images, videos, audio recordings. Then in sensor and IoT data, you will be having weather data, surveillance camera feeds, and web content, you will be having news articles, blogs, Wikipedia pages. Okay. And here, because the traditional databases, this cannot process unstructured data efficiently, the technologies which are used to efficiently process this unstructured data are the big data frameworks. Then it is NoSQL. Okay, that may be databases, that may be MongoDB. Then you have uh, advanced analytics. Okay, and you will be having machine learning and the artificial intelligence. Next is characteristics of the big data. So big data, it is defined by certain characteristics commonly known as the three V's. Okay, V, that is V for van. It is three V's through some authors, and it may be extended up to it is extended up to 7 V's for a more comprehensive by some authors. So the core three V's are the volume, velocity, and the variety. So the volume, it is the amount of data that is being generated in is massive, and it is often in petabytes or exabytes. Example is the Facebook generates over 4 petabytes of data daily. Then you have velocity, where the speed at which the data is generated, processed and analyzed is extremely high. Example is the stock market data, which will be updated every milliseconds. Then you have variety, that is the data comes in different formats. That is it may be structured, unstructured, semi-structured. And the additional 4 V's are the veracity, value, variability, and the visualization. Veracity is, it is nothing but the ensuring the quality, accuracy, and reliability of the data. And here the challenge is the social media post, it may contain misleading information. Then you have value, which is extracting useful insights from the big data to make informed decisions. And example here is the e-commerce platforms which use customer data for personalized recommendations. And you have variability, that is the inconsistency in data flows and formats over time. Example is weather forecasting systems which deal with irregular climate patterns. And the last one is the visualization, that is presenting complex big data insights in an understandable format. Okay, and here the example are the dashboards, charts, then graphs, which make the data easy to interpret. These all are the characteristics of the big data. Here you have mainly three characteristics, or these are called as the core 3 V's, and these are the additional 4 V's. So we will see one by one in detail. The first is volume in big data. Volume in big data, it refers to the huge quantity of the data, that is the large amount of data which is being generated every second continuously, and it is increasing continuously. Now as the world becomes more digital, the amount of data collected, it grows exponentially. Okay, and here the key aspects of the volumes are of this volume in big data is large amount of data where the data is generated at massive scale, reaching the terabytes and petabytes or even exabytes. And here it continues new data sources. It includes IoT devices, social media, sensors, and transactions which contribute to the growth. Then you have scalable storage solutions. That is, traditional databases, it cannot handle large, vast amount of data, leading to the use of cloud storage, Hadoop, and distributed databases. So examples of big data volume are astronomy data, social media and video streaming, e-commerce, finance. In astronomy data, you have LSST technique, that is the large synoptic survey telescope, which generates over 32 terabytes of images every night, which are used for space research. Okay, this is about the LSST telescope. Then you have social media and video streaming. Under this, you have YouTube uploads where 70 hours of video are uploaded every minute, and Facebook data generation that will generate over 4 petabytes of data per day. Then you have e-commerce and finance. Here you have Amazon transactions and stock market trades. In Amazon transactions, it processes hundreds of terabytes of transaction data daily, and the stock markets, billion of trade records are generated every day. Okay. Next is the velocity. The velocity, it refers to the speed at which the data is generated and collected and processed. Now here the data is produced and analyzed in real time, enabling the faster decision making. So the key aspects are the rapid data generation, where data is being created at an unpredicted rate from various sources like social media, IoT devices, stock markets, and the online transactions. And the need for real-time processing is the organizations require real-time insights in order to improve the efficiency and the user experience. Then you have the limitations of the traditional processing, where the older batch processing techniques which cannot handle the high speed data lead to the adoption of streaming technologies like Apache, Kafka. Then you have Spark streaming. And the examples are social media activity, where in Twitter you have 140 million tweets per day. That is according to the 2011 data, and today it is much higher. Then you have Facebook, which generates 4 petabytes of data per day. And next is the stock market transactions. So according here the NYSE, that is the New York Stock Exchange, it will generate 1 terabyte of exchange data per that is the trading sessions. And you have IoT and sensor data. So here you have smart cities, that is which use the sensors in order to monitor the traffic, weather, and energy consumption. And you will have here the self-driving cars which process data from cameras and the sensors. And here this can be like a velocity. It plays a very important role in Industry 4.0 and IIoT, where the machines and the sensors, these will generate high speed data for automation and the decision making. Here it can be used for manufacturing, healthcare, retail, and e-commerce. The next V is the variety in the big data. So variety, it refers to the different types and formats of data that are generated from various sources. And here big data includes a wide range of data formats, making it more complex in order to process and analyze the data. So the key aspects are the different categories of data. Okay, that is, it may be structured, semi-structured, or unstructured. And you have the formats of data. It may be text data, multimedia data, or the sensor and IoT data. And in industrial applications, it can be used in manufacturing, healthcare, and retail and e-commerce. So next is the variability. in big data. Here the variability, it refers to the changing nature of the data over the time. That is, it is different from variety, which deals with different types of data formats. And variability, it focuses on how the meaning, context, and the structure of the data change dynamically. Okay, these are the key aspects. That is the change in the meaning, then context dependence and analysis challenges. So here data is unpredictable and fluctuates over the time, and data interpretation, it changes based on the usage, location, or the time. And it is very difficult because it is very difficult to analyze the data, because without proper artificial intelligence and machine learning tools, such data appears to be unstructured and indecipherable. Okay, and here the examples are the natural language processing. The meaning of the words and the phrases changes based on the context, slang, and the cultural trends. Then you have social media trends and the hashtags, and geospatial data, where the location based data changes depending on the time, traffic, and the movement. Example is the Google Map route, which may suggest different paths based on live traffic updates. Then you have multimedia and sensor data, where the sensors readings vary due to the temperature changes, network fluctuations, or the device errors. And example here is the weather station data, which changes due to sudden climate shifts. Next is the veracity in big data. Veracity, it refers to the trustworthiness, accuracy, and the reliability of the data. Because the big data, it comes from multiple sources, it is often it contains bias, then inconsistencies, noise, or errors which can affect the decision making. And here these are the key aspects, that is bias and uncertainty, where the data can be incomplete, misleading, or the imprecise. And next is the automated decision making. So here this is essential, as the AI systems will rely on the high quality unbiased data in order to make accurate predictions. Then you have unsupervised machine learning, which is very important, because poor quality data, it can mislead AI models, resulting in incorrect conclusions. Then you have context and relevance. That is veracity focuses on understanding the context and the relevance of the data, not just its accuracy. Okay, so here it is more than the data quality. Okay, so examples are the social media and the fake news, where not all the tweets, posts, or the reviews, those will be authentic, and some may be spam or fake news or misleading content. Example here is a fake review on Amazon, which can mislead the buyers and affect the recommendations. Then you have medical data and diagnosis, where inconsistent or missing patient records can cause AI misdiagnosis. Okay, and financial data and fraud detection. Banks must verify the transaction legitimacy to prevent the fraud. For example, a financial system, it will analyze the stock prices. It needs to filter out the outliers or the sudden price spikes which are caused by the errors. Then you have IoT and data sensor data noise. That is a sensor data noise, where the sensors may malfunction or they may record the incorrect values due to the environmental conditions. Next, you have visualization. Here, visualization, it refers to the representation of the data in the form of graphs, charts, heat maps, dashboards, or the infographics. Okay, and it will help the decision makers to understand the complex data easily, because the big data, it involves massive amounts of information. The visual tools will allow the patterns, trends, and insights to be quickly identified. Then the key aspects here are the graphical representation of the data. Then you have it simplifies the complex information. That is, it makes it easier to identify the patterns, trends, and the relationships. and you have essential, that is, it is essential for decision making, that is business leaders, analysts and the researchers use data visualization for faster and more effective decisions. Then you have supports predictive analysis, which will help in forecasting the sales trends and risk using AI powered visual analytics. Okay, so some examples are the business intelligence dashboards, like tools like you have Power BI, Google Data Studio, which creates interactive visual reports, and you have social media analytics like word clouds and the sentiment analysis graphs, which help which help to track the public opinion. For example, Twitter's trending hashtags. These can be visualized using a heat map. Okay. You have stock market and the finance, that is candlestick charts and real-time dashboards. It will help the investors to monitor the stock trends, and it may be used in health trends. It may be used in IoT and Industry 4.0 monitoring, that is the smart factories use the real-time visual monitoring in order to track the machine performance. Okay, so here these all are the key aspects of the visualization, that is graphical representation of data, and it simplifies the complex information, and it is essential for decision making, and it also supports the predictive analysis. Next is the value in big data, where the value refers to the ability to extract the meaningful insights. Okay, and from the large unstructured data, and simply collection of data is not enough here. It must be analyzed and it must be converted into an actionable knowledge. So here this will transform the raw data into the business insights. That is, it will help the companies make data driven decisions, and it improves the efficiency and the profitability. That is, it identifies the trends, risks and the opportunities, and also it enables the real time decision making. That is, AI and the big data analytics, it will help in industries to react quickly to the market changes. So these are the key aspects of the value in big data, that is transforms raw data into business insights. It improves efficiency and the profitability, and also enables the real-time decision making. Next is the data sources in the big data. So here the big data, it comes from the multiple sources across industries, and these sources will contribute to the vast amount of structured, semi-structured and unstructured data that organizations use for decision making, automation and analytics. So the key data sources in the big data are the biomedical data, um, where you have gene sequencing data, which is generated from the DNA sequencing and the genomics research. Then you have medical clinic data, which includes the electronic health records, patient history, then lab reports. And you have wearable health devices, where the data from the smartwatches, heart rate monitors and glucose sensors, etc. Okay, then you have computational biology, that is data from the protein analysis, that is a protein structure analysis, then drug discovery and DNA simulations will be used, and it helps in cancer research, vaccine development and personalized medicine. Example here is the NASA's James Webb Space Telescope, which will capture the high resolution cosmic waves or the images and generates vast data sets for the analysis. Then you have nuclear research. Okay, here where experiments in the nuclear reactors and the particle accelerators generate the petabytes of data, and it is used in nuclear energy optimization, radiation studies and quantum physics research. And another source is the astronomy, where the telescopes and the space observations collect the terabytes of cosmic data daily, and these are used in astronomical simulations, black hole studies and the planet tracking. Okay. Now, next you have data acquisition in big data. That is, it is a process, data acquisition, it is a process of collecting, transmitting and pre-processing the data in order to ensure the quality and usability before the analysis of the data, because this big data, it is generated from various sources. Proper acquisition, it is very important for efficient storage, processing, and the decision making. And the steps in the data acquisition are the data collection and the data transmission. So here the data, it is automatically recorded by the sensors, mobile devices, web services. And here the sources include log files, IoT devices, then you have GPS trackers and the social media cameras. Example are smartphones, and you have web servers. Then data transmission, after collection the data, that is after you collect the data is transmitted to storage systems or the data centers for further processing. Here you have two categories of transmission. First is the inter-DCN transmission and second is the intra-DCN transmission. Here inter-DCN transmission, it is the data transfer between the different data centers, and intra-DCN transmission, it is the data transfer within the same data center. Okay. So data pre-processing, once you have done with this, next stage is the data pre-processing, where the raw data is cleaned and it is refined to ensure the quality. So pre-processing, it will ensure the data quality and the reliability. So these are the steps of the pre-processing, data pre-processing. First is the integration, which will combine the data from the multiple sources in order to create a unified data sets, and it removes the inconsistencies between the data sets from different databases. Here the example is merging customer purchase history from an e-commerce website and a mobile app. Then second is the data cleaning, that is the clearing of the data, which where it identifies and removes the incorrect, incomplete or inconsistent data, and it fixes the errors such as duplicate values, then missing entries and the formatting issues. For example, in a hospital database, missing patient birth data are filled or flagged for correction. Then third is the redundancy mitigation, where it detects and eliminates duplicate data in order to reduce the storage and the processing cost. And it uses the data compression, filtering, and duplication techniques. For example, removing the identical sensor readings from an IoT network in order to avoid unnecessary data storage. So these are the three data pre-processing steps, that is integration, data cleaning, and the redundancy mitigation. Then next is the data storage in the big data. Efficient data storage, it is very important for managing the large amount of structured and unstructured data which is generated in the big data systems, and the storage solutions must ensure scalability, accessibility, consistency, then and also the fault tolerance to handle the massive data sets. So here these are the databases which are used, you will be using NoSQL databases, which has these features, that is scalability, schema flexibility, and high speed read or write. Okay. Just a minute. Okay. Then next you have coming to this distributed file systems. Here these store the data across multiple nodes in a network, and these will ensure the scalability, that is it can handle large data sets by adding more storage nodes, and that is next is the fault tolerance, where the data is replicated across multiple locations in order to prevent loss, and high availability is data remains accessible even if some nodes fail. Okay. And last examples, for example, here you have a Google file system, that is a GFS, and you have Hadoop distributed file system, that is a HDFS, and These are here not only SQL. Okay, it is no SQL is not only SQL. So here to overcome like in traditional databases, that is a traditional relational databases, that is the RDBMS, these struggle with big data due to the scalability issues and the rigid structure. Okay, because these are hard to manage the petabytes of data, and these can't efficiently handle unstructured data like videos, images, and the social media post. So in order to overcome these limitations, no SQL, that is not only SQL databases are introduced, and these are designed for scalability, schema flexibility, and the high speed read or write. Now next is why this data analytics is done. Because here as we have large amount of data from various sources like sensors, IoT devices, social media, and business systems, it has become very essential to analyze and extract the meaningful insights. And whatever data we have, all the data is not useful, and some may be irrelevant or redundant or noisy. So the data analytics, it will help to identify, process, and interpret the valuable data for better decision making. So here the data analytics, it is used for filtering the relevant data, that is identifying the relevant data. As all the data which is collected, it is not valuable, some may be redundant, incomplete, or unnecessary. So the data analytics, it will help to identify relevant and actionable information. Then next is the managing large scale data. Okay. So here you have the like uh, traditional data processing tools which cannot handle the volume, variety, and the velocity of the modern data. Advanced analytics tools like the and big data analytics, artificial intelligence, and machine learning will help manage the data sets. Then you have real-time decision making. So here uh, you will be having like immediate analysis of the data, which allows for quick and effective decision making. Okay, and next is the improving business intelligence. So here the business use data driven insights in order to enhance the customer experience, sales, and the efficiency. So here data analytics helps in predictive modeling and the trend forecasting. Okay, so this data analytics, it plays a very important role like in identifying the data, relevant data, that is filtering out the noise and focusing on meaningful information. Then you have enhancing the decision making, that is it will provide the actionable insights for real-time applications, and it will adapt to changes. Then next is the optimizing storage and the processing, where it reduces the data overload and improve the system efficiency. And in the next we have detecting patterns and trends, that is it will support the predictive maintenance and automation. Then you have anomaly detection. Okay, so by leveraging the data analytics, organizations can maximize the potential of the sensor generated data and ensure smart and more efficient operations. These are the key benefits of the data analytics in business. First is it will help to learn about the competitors. Okay, that is the competitor analysis. And next is it will help to join an activity which will expand the business, that is the business expansion. That is it will identify emerging trends, customer demands, and profitable opportunities, and also it will protect from wrongful decisions. Okay, so here the data driven decision making reduces the risk by providing factual insights. Then you have improve market effectiveness. Okay, yeah. So here Like businesses, these can analyze customer preferences, buying behavior and feedback in order to fine tune marketing strategies and increase the engagement. Then you have enhance operational efficiency, okay, where data analytics optimizes the processes, it reduces the waste and improves the resource allocation, and it will lead to a better efficiency and the cost savings. Then you have appropriate product recommendations, where by analyzing user preferences and the purchase history, the business can personalize the recommendations, improving customer experience and the increasing sales. So these are the key benefits of the data analytics, that is operational efficiency, competitor analysis, risk mitigation. Then you have market effectiveness, business expansion and the product recommendation. Then you have big data analytics versus the traditional data warehousing. So here the big data refers to significantly like it differs significantly from conventional data warehouse approaches due to its volume, variety and the velocity. Okay, so here the big data, uh, traditional data ware approaches or the systems like extra data or the teradata, these rely on structured data which is stored in the relational databases. And the big data, it deals with structured and semi-structured and unstructured data, making traditional warehouse architectures unsuitable. Okay, so here the traditional data warehousing systems, these will rely on only the structured data, whereas the big data, it deals with the structured, semi-structured and unstructured data. And scalability issues in traditional data warehousing is these architectures are limited in handling massive high-speed data streams, whereas big data applications require scalable frameworks in order to process the data efficiently. And modern big data frameworks, here the distributed computing, that is used instead of centralizing the data. Big data systems distribute storage and processing across multiple nodes. Then you have massive parallel processing, that is the MPP, where the frameworks like Hadoop, Spark and the not only SQL databases like MongoDB enable high speed parallel data processing. Then you have scale out approach, where instead of upgrading a single system, big data solution add multiple interconnected nodes for better performance and the cost effectiveness. Next you have big data analytics for industry 4.0. Here first here the key aspects are sensor data processing for actionable insights. Okay, that is the sensor data processing, where thousands of industrial sensors, these will generate massive data streams, and the data must be collected, stored, optimized and analyzed in order to extract the meaningful insights. So for example, you have a sensor which detects anomaly in a machine's operation, and it will record the event in an operational recorder, that is the database, for further analysis. Then you have big data in healthcare and manufacturing, where the challenge of handling large data sets in healthcare and manufacturing, it is not new, but here example is that is in manufacturing, real-time analysis, it can improve or it can compare hourly production metrics against the predefined norms to detect the inefficiencies or the faults. Next is the role of industrial IoT in big data analytics. So here this IIoT, it is a major driver of the big data. It will enable the smart factories, predictive maintenance and the process optimization. Then some of the new technologies for managing the big data are the cloud computing and the Hadoop. So cloud computing, it will provide unlimited on-demand storage for handling the large data sets. And Hadoop, it is an open source cloud-based distributed data storage system which is widely used for managing the industrial IoT generated big data. So next you have the features and benefits of the cloud-based analytics. The uh, first feature is you have on-demand self-service, where users can access computing resources as needed without requiring human intervention from the service provider. And example here is a data scientist who can launch a virtual machine for running big data analytics instantly. Then you have wide network access, where the cloud services are accessible anytime, anywhere via the internet using multiple devices. That is, he can use laptops, tablets, mobile phones. An example here is a factory supervisor. He can monitor the real-time sensor data analytics remotely. Then you have method grouping, where the here method grouping, that is cloud platforms, these will offer various pre-built services for the analytics such as data storage. Then you have, that is, in data storage you'll be having Google Cloud Storage. Then second is the big data processing like Hadoop, and AI and ML tools, that is the TensorFlow, Azure, machine learning. Then you have fast flexibility, that is the rapid elasticity, where the resources can be scaled up or down dynamically based on the demand. Example here is a retail business can increase computing power during the peak sales periods and scale down after in order to save the cost. Okay, and the last is a measured service, cloud providers use the pay as you go, where pay as you go model, where users are charged user are charged based on actual resource usage. And this ensures the cost efficiency and prevents the waste of resources. Okay, next is you have types of data analytics and their applications. So here the data analytics, it can be categorized into three main types. Each will serve a specific purpose in the decision making. The first one is the descriptive analysis. Here it will tell you what has happened. That is, it will focus on analyzing historical data in order to understand the past events, and it answers when, where, and what happened. For example, in manufacturing, descriptive analytics tracks the production downtime and identifies the failure patterns. And in retail, it will summarize past sales performance in order to evaluate the business growth. Then second is predictive analytics. That is, it uses the statistical model and machine learning in order to identify patterns and predict failure outcomes. And here it will answers what's next and what pattern do we see. For example, in healthcare, predictive models, these will forecast the patient health risk based on the past record. Then third is the prescriptive analysis. Here it recommends actions based on data-driven insights in order to achieve the best outcomes. So here it answers what is the best action and should we try this. Okay. Example here is supply chain management, uh, and you have the industrial IoT also, where the AI powered system, it will adjust the machine settings dynamically in order to improve the efficiency. So this was about the big data and the advanced analysis. Thank you.